Okay, here's another in our series of mechanics problems. In this one, a car is traveling at a constant velocity and then it accelerates, and we're given the acceleration rate, 1 meter per second squared. And it accelerates for a period of 12 seconds, and it travels 190 meters during this period. And that's all we know. And we want to find the velocity of the car before it began. Well, the thing that I like to do first is to draw a little timeline like this, and put on that timeline everything that we know. We know the acceleration, we know the time, and we know the distance that the car went during that time. Okay, now all of our information is well organized and ready for us to use. So we'll start this problem by writing down the definition of acceleration, delta v over delta t. Now let's look at that and see what we have. We know the acceleration, 1 meter per second squared. We don't know the final velocity or initial velocity of this vehicle, but we do know that the time elapsed during the acceleration is 12 seconds. Now another thing that we know is the average velocity of this car, which is distance over time, and we know that the car travels 190 meters over 12 seconds, which gives us an average velocity of 15.83 meters per second, assuming that the acceleration is smooth and constant. Now to solve a problem like this, we need all the tools in our toolbox. So another way to write the average velocity is by just averaging the initial and final velocities. Add them together and divide by 2. Now let me just come up here and rearrange this acceleration equation by saying that AT is equal to V final minus V initial. And let me rewrite this average velocity as 2V average is equal to V final plus V initial. Now just transfer that other equation, AT is equal to VF minus VI, and write it underneath. Now watch what we can do. We can subtract the lower equation from the upper equation. And what that will do for us is allow us to get rid of the variable V final. So we'll really only have one variable in here. We have twice the average velocity minus the acceleration times the time is equal to 2V sub I. And if I solve for V sub I by dividing by 2 on both sides, I get this nice equation for the initial velocity. And then I just have to plug in my numbers. Initial velocity is equal to 2 times the average velocity, 15.83 meters per second, minus the acceleration, 1 meter per second squared, times the time, 12 seconds, and that is all divided by 2, and I can check out my units there and note that they'll come out in units of meters per second, and so I get the initial velocity is 9.83 meters per second.